lesson is over the rules of probability. Before we begin, let's review some facts. Remember that the capital sigma means summation notation, so whatever follows that you need to add together. If you see a capital P with parentheses after it, all that means is we're trying to figure out the probability of an event. And as we went over in our last lesson, we want to remember that mutually exclusive is if one event happens, it prevents the other event from happening. Independent events are events that if one event occurs, it has no effect on the other event occurring. And dependent events, if one event occurs, it impacts the probability of the other event occurring. You're going to see two symbols in this lesson on the rules of probability. When you see a capital E, and it'll have a subscript E1, E2, or E3, so that would mean the first, second, or third event. That just means the event you're talking about. Lowercase e would mean the different outcomes that are available in that event. For example, if our event is rolling an even when we roll a dice, the different outcomes, which would be lowercase e, could be 2, 4, or 6, E1, E2, E3. So those are the three different outcomes that give us that event of rolling even when we roll a dice. We're going to be going over 10 different rules of probability, and then I'll give you some hints at the end to help you when you have to work these problems. The first three are pretty self-explanatory. The probability of any event is always going to fall between a 0 chance and a 1 chance. Remember that 0 means it will not occur, and 1 means it definitely will occur. 1 is the same as if you take the number 1 and turn it to a percent. Remember, that's 100%. So all probability will fall between 0 and 100%. The second probability rule, you see the sigma notation. That means if we added up all the different outcomes for a certain event, it would add up to 1. Or all the different outcomes of a certain probability would add up to 1. So if we added up the probability of rolling the heads, or tossing a coin and getting the heads, and the probability of getting the tails, it adds up to 1. The third rule of probability is if you have an event, and let's say it has 3 different outcomes, if you want to find out the probability for that entire event, you just add the probability of the different outcomes that make up that event. So we used previously the example of rolling an even on a die. So we'd add the probability of rolling a 2, plus the probability of rolling a 4, plus the probability of rolling a 6, and that'll give us the probability of our entire event of rolling an even number. The next probability rule is the complement rule. And this is easily understood if we look at an example. So let's say our event is that it will rain outside, and let's say the probability of that event is 10%. The complement of that, which you want to think that's the opposite of that, would be the probability that it wouldn't rain, which would be 90%. So what did we do in our head to get that 90%? We just said 100% minus 10%. So that's all the complement rule is the probability of the complement of a certain event. So the opposite, you just take 100% minus your original event, and you'll get the answer. The fourth rule of probability is the addition rule. Let's look at an example from a classroom. Let's say a class is made up of 25 different students. 18 of those students have brown eyes, and 20 of those students have brown hair. So if we said, how many have brown eyes and brown hair? Well, that adds up to 38, right? Well, if we only have 25 students, how can we have 38 of those students have brown eyes and brown hair? Well, obviously, some of the students have both. And this is easily understood by looking at a Venn diagram. If our event 1 is brown eyes and our event 2 is brown hair, we do have some students that fall into the category where they have brown eyes and brown hair. So when we're figuring out this probability, you would take the probability of E1 plus the probability of E2, and then you have to subtract that shaded overlapping area that contains the items or the individuals that fall into both categories. And that's why they subtract the probability of E1 and E2. The next probability rule is also the addition rule, but this is for mutually exclusive events. And remember, mutually exclusive events are events that if one event happens, it prevents the other event from happening. So, for example, if event 1 is being born in Texas and event 2 is being born in Italy, well, are those mutually exclusive events? Yes, so they both can't happen, so there's no overlapping area, so there's nothing to subtract. All you would have to do is just add the probability of event 1 plus the probability of event 2, and for mutually exclusive events, you don't have to subtract any overlapping area. The sixth probability rule is called conditional probability. And a hint that you're working with conditional probability is when you see the words given that. That's what that line means. The probability of event 1 given that event 2 has occurred. And the formula looks kind of complicated, but let's look at a few examples to kind of clear this up for us. Let's say we wanted to figure out the probability that if we randomly chose one person out of the whole world, that person would own a truck. Well, the probability of that is probably pretty low. But if we put a conditional statement on them, let's say event 1 is owning a truck and event 2 is that person lives in Texas, then the probability of event 1, given that event 2 is true, the probability of owning a truck, the percent would be a lot higher. So the probability that one event will occur given that some event has already occurred is conditional probability, and you'll use this formula here to the right. Let's look at another example, and this example is going to be based on this chart. We have a group of students that are both male and female, and they're divided up into their classes. If we randomly choose a student from this, we want to look at this using a conditional probability problem. Given that the student is a senior, what is the probability that the student is a female? So if E1 is female and E2 is senior, if we use the formula, we're figuring out the probability that the student is a female given that they're a senior. If we look on this chart, in the numerator, the E1 and E2, we can see that 3 of these students are females and seniors out of the total 42. So that'll go on the top of the fraction. In the denominator, it says just put the probability of E2, which is the probability that they're a senior. We see that 5 of these students are a senior, so that would be 5 out of 42 that goes in the denominator. After you do the math, that comes out to 60%. A lot of the conditional probability problems you're going to do, you're going to be given a table, so there's kind of a shortcut where you can directly look at the table and find the answer. If we want to find out the probability that the student is a female given that they're a senior, so we're going to limit what we're looking at. There's only 5 seniors, and out of those 5 seniors, 3 are female. So that's 3 out of 5, which is also 60%. That's the shortcut way to do it.